We are still in Unit 2.3. This is sections 2.4 and 4.9, day 2. So if we're looking at a table of values and the x values are equally spaced, so that means the same jump to get to each one. It could be 1, it could be 2, right? It could be 2, 4, 6, 8, 10, and so on. As long as they're equally spaced, the differences of consecutive y values are called finite differences. So between 9 and 4, it went down by 5. Between 4 and 1, it went down by 3, and so on. We can make this whole chart. So the first differences are not the same for this set of values. But if I now take the difference between those, from -5 to -3, we went up by 2. From -3 to -1, we went up by 2, and so on. The second differences are the same. So what this tells us, if a polynomial function has a degree of n, then it's the nth differences that will be constant for equally spaced x values. And conversely, if the nth differences of equally spaced data are non-zero and constant, then it can be represented by a polynomial function of degree n, which means if it's common first differences, it's a degree of 1. If it was common second differences, then it's a degree of 2, and so on. So looking at our first example, we're going to use finite differences to determine the degree of the polynomial function that fits the data, then find the polynomial function. So I'm going to start by finding the first differences. We notice the x's are all equally spaced, so we're good. Get from 2 to 7, I went up by 5. 7 to 13, we went up by 6. 13 to 20, we went up by 7. 20 to 28, up by 8. And 28 to 37, up by 9. So they're common the first differences are not in common, right? They're all different. So now I'll go to second differences. To get from 5 to 6, up by 1. 6 to 7, up by 1. 7 to 8, up by 1. And 8 to 9, up by 1. So the second differences are common. Which means it's a degree of 2. And if you recall from our previous lesson, if I want to write a quadratic, I'm going to take 3 points, make the equations, create the matrix, and then find the reduced row echelon form. So if I use the first 3 points, remember we're using x squared a plus xb plus c equals y. So that would be 1 squared or 1a plus 1b plus c equals 2. 2 squared or 4a plus 2b plus c equals 7. And 3 squared or 9a plus 3b plus c equals 13. So turning this into a matrix, 1, 1, 1, 2, 4, 2, 1, 7, and 9, 3, 1, 13. So this is what I would take over to my Desmos calculator. Get a 3x4 matrix there. And find the reduced row echelon form. So it looks like we have positive 1/2 for A, positive 7/2 for B, and negative 2 for C. So A was positive 1/2, B was 7/2, C was negative 2. So that means we're going to have y equals 1/2 x squared plus 7/2 x minus 2. All right, looking at my next problem, same directions, use finite differences to determine the degree of the polynomial that fits the data, then find it. So first differences, we had minus 12, minus 6, plus 3, plus 15, plus 30, plus 48, and then plus 69. So those first differences are not the same. Then to get from negative 12 to negative 6, we went up by 6. then we went up by 9, then 12, then 15, then 18, then 21. And now going to our third differences, went up by 3, up by 3, up by 3, 3, and 3. So we had common third differences, which means the degree is 3, right? This is a cubic function. And if you remember cubic, we had x cubed a plus x squared b plus xc plus d equals y. So we're going to take, again, 3 points. I'm going to stick with the first 3. So 1 to the third is 1. 1 squared is 1. Plus 1. D equals 24. 2 to the third is 8. 2 squared is 4. And 2. Oh, sorry, remember we had to do 4 points, not 3. Because degree 3, 4 points, 4 equations. 3 to the third is 27. 3 squared is 9. And now 4. 4 to the third is 64. 4 squared is 16. That's 4. Okay, so that means the matrix we're going to use is 1, 1, 1, 1, 24, 8, 4, 2, 1, 12. All right, the rest of those points in. Okay, so we'll bring this over to our calculator. Let's clear everything out. Now I want a 4 by 5. Oh no, I got rid of it. Oh, come on. Oh, goodness, I'm all over the place. Okay. So, find reduced row echelon form. And we have 1/2, 0, negative 31 halves, and 39. So A was 1/2, B was 0, C was negative 31 halves, and D was 39. We could have kept those as decimals if we wanted. They were all kind of nice. So we have y equals 1/2 x to the third plus 0 times x squared, so I'm going to skip it, minus 31 over 2 x plus 39. All right, you can try the next 2, pause it, and when you're ready, play to see the answer. Alrighty, let's check our answers. So for A, I ended up with a common third difference, so the degree was 3. I skipped over 0. You don't have to. I just, I don't know. I always skip over 0 for some reason. This was my matrix that I used based on the equations that I didn't write here. So my final answer, I got y equals negative x cubed minus 7x squared minus 7x plus 21. It doesn't matter what 4 points you use. You should get the same answer. And then for B, I had common second differences, so the degree was 2. So here is my matrix made up from the equations that I didn't show. So I ended up with y equals negative 3x squared plus 30x plus 12. And that is day 2 of sections 2, 4, and 4, 9.